This podcast is sponsored by Echelon. Echelon is the affordable way to get the workout equipment, the workout community, and an instructor's motivation right in the comfort of your own home. With Echelon, you can work at any time, day or night, and crush your fitness goals. And right now, for a limited time, podcast listeners get up to $800 off MSRP. To get this exclusive podcast discount, text GENIUS to 818181 to get up to $800 off MSRP. Once again, just text GENIUS to 818181. Quick disclaimer, message and data rates may apply. See terms for details.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Mikael Attal. He's part of the School of Geosciences at the University of Edinburgh. He's a geomorphologist, which I'm going to ask him about. So, Mikael, thank you for coming.
Thank you for having me here.
If you would, tell me about your work. What does a geomorphologist look at? And then I want to ask you about your background.
Yeah, so I'm a geomorphologist, which means I study the processes that shape the Earth and the hazards that are associated with them. So the Earth is a changing shape through erosion processes. You can have landslides, you can have earthquakes, and so on. And I'm looking at how these processes lead to the landscape we can see. And I focus particularly on sediment. And sediment, it's all the debris that are rock debris that are produced in the mountains. And I look at how they evolve from the place where they're born in the mountains, and how they get transported by rivers, how they change in rivers, and how they get turned into gravel and sand, and these sort of products that we're seeing regularly.
What got you into this field? It sounds like an unusual thing to research.
Yeah, it's quite unusual. So from when I was a little kid, I was passionate about dinosaurs, minerals, fossils, volcanoes. I grew at the time when we had French volcanologists like Maurice Krafft and Katja Krafft, Harun Tazieff were bringing us this wonderful image about volcanic eruption and all that. And I got really passionate about that. And this passion did not subside. My parents had other plans for me, like they thought that geologist is not a real job, but they eventually changed their mind and let me go to university to study geology. And I would say that I started as a geologist, but so really looking at how the Earth is evolving on geological timescale. But then I moved into geomorphology during my PhD, and that's when I started looking at how we can look at the shape of landscape to learn things about what's happening on the ground. Like in terms of geology.
What's an example of a localized area that has dramatically changed due to erosion or movement of sand or soil or gravel? Like, what's an example that you've researched?
So I mean, I'm doing some research in the Himalaya, for example, and this is places where you've got big, powerful rivers. And so there's a couple of things. There's earthquakes. That means that when there's an earthquake, you can have a lot of landslides, for example, that are going to change the shape of the landscape. And these landslides are going to bring a lot of sediment into the river. And then this river is going to transport that sediment, and that can lead to deposition, that can lead to erosion. And the Himalaya also has this monsoon climate, which means that most of the time there is not much happening. But during the monsoon, the rivers become very big, very powerful, and they can cause a lot of erosion and change their course as well, depending on how much sediment they transport. So these are very dramatic changes that can operate in a few days, can affect people who live by the river.
So what are some of the factors that would mitigate a river swelling and overflowing its banks and flooding an area versus not?
Well, so this is one of the things that becomes interesting, actually, because a lot of people think that flooding is just water. And I think it's really recently that people have been started really looking at sediment and how sediment can change the shape of a river. So, for example, if there's an earthquake and there's a lot of sediment that ends up in the river may deposit that sediment, and that may raise the bed of the river. And by doing so, the river is suddenly has much less capacity to hold water. So the shape of the river from the outside may not look very different, but the water coming during a flood that would have not caused flooding may suddenly overflow and cause damage to the people living on the side. And that's not just in the Himalaya, that is worldwide. Sediment is being transported, deposited, and this is something that people have overlooked, I would say.
It sounds like each major weather event sets up an area for future possible issues or changes.
I would agree with that. And in particular, it looks like with the climate, the way the climate is changing at the moment, extremes are becoming more and more frequent. We see that with extreme hurricanes, extreme fires, and extreme storms are also becoming more frequent. So suddenly you've got rivers that have much more water, that are more powerful, that can flood more, but also transport more sediment. Yes.
So what's a case study of a sudden flood or monsoon, and what did it do to a given area, and what happened later on in that area? Do you have any good case studies that you can talk about?
Yeah, I mean, staying in the Himalaya, for example, there is the Kosi River, which is it's in eastern Nepal, and it flows into India. And in 2008, it had a major avulsion event, which means that the river changes its course and it moved by 30 kilometers in some place. So it moved 30 kilometers eastwards, which means that people who used to live by the side of the river suddenly had no river anymore. And the people who were living where the river decided to move had to be displaced. So that event displaced 3 million people. And in the following years, they built an embankment. They rebuilt an embankment to force the river back to where it was. So the places that had been flooded had been suddenly covered in sand, and they became very infertile. So people who were living there, even now, more than 15 years, around 15 years later, you can still see that in satellite imagery. Plants have not been growing as they were before, so you can still see the impact of that event, even from satellite imagery.
So what are some of the events that seem to be the most disruptive to a given area, that change it the most, either in an obvious way or in an unobvious way, that causes problems later on?
So I think one way to answer to that question is to think about, in particular, in this particularly dynamic environment, like active mountains, we're talking about Himalaya, the Alps, Taiwan, and so on. People are realizing more and more they're talking about a cascade of hazards, which means that an event in itself, you would think, okay, there is a big storm, so there's going to be a lot of water, so it's going to have a big impact. But actually thinking that other events, when that happen further upstream, can actually make the event worse. So, for example, if there's been an earthquake before, that's going to generate a lot of sediment on the hillside. And if a big storm happens after this earthquake, then that sediment is going to end in the river, and that's going to make things worse. So one of the directions that the research is going at the moment is to start looking at this cascade of hazards, thinking not about one hazard in isolation, like earthquake, landsliding, volcanism, flooding, but just thinking about how, when they happen one after each other, they can tend to make things much worse than you would imagine if you just look at one particular hazard. And I think that's very interesting. And there are some really novel ways of approaching these problems that are being developed, and in particular, how it can impact population and people living in these hazardous areas.
Well, what's a geography that's prone to problems? Do you have a valley with a river running through it, or I don't know if the elevation changes suddenly near a river, or what areas seem to be prone to future problems?
Yeah, so for example, it almost makes you think that there's no single area that's going to be safe, because if you have steep slopes, so for example, I'm thinking about, anywhere in the world, the rivers are going to start somewhere in the mountains, and they're going to end up into the sea. And before they reach the sea, they will become wider and flatter, and you will have low-lying area, floodplains, and so on. So in terms of flooding risk, the areas that are in the low-lying areas are going to be more vulnerable. So we see that in the UK, for example. We see that, there's been, for example, a lot of flooding in Europe past year. The flooding is going to happen mostly in the places where you've got low-lying area. You've got a channel that people try to constrain, usually using embankments. You've got people living on the sides, and then the river breaches banks and you get the flooding. So low relief is your enemy in that case in terms of flooding. But if you go into the river, you've got into the mountains, you're going to have steep slopes. So if your house is built on the hillside, you're further away from the river, so you're less likely to have flooding, but you can have landsliding and debris flows and this sort of additional hazards. So in this case, you have a different type of hazards that may also be triggered by a storm, for example.
No, I'm just trying to wonder again, what areas that you've studied in particular that you were really surprised about what happened. You had no clue that because of rain or because of some other event that an area would change to a degree where it now completely reacts differently to new storms and new problems.
Right. Okay. So, in terms of the surprises that I had in my research, so, for example, it's how quickly you would think about big rivers, but I've done some work in Iceland, for example, where we were looking at the impact of big floods. So when you have volcanoes erupting under glaciers, for example, that can trigger very, very big floods, like some of the largest floods that the Earth has experienced. And there is also examples of very big floods in the US, for example, in the Western US, where during the last glacial maximum, you had lakes that were sitting behind glaciers. And as these glaciers were melting, the lakes emptied over the landscape and created a lot of erosion. And there's been new techniques that have been developed to date these erosional features. And what we've been able to show, for example, is that some of these big canyons in Iceland have been created in a few hours, maybe a few days during one of these big floods. And there is also some idea that the scablands in the Western US, as we call them, may have been created in a matter of days as these big lakes emptied over the landscape and were extremely powerful and carved canyons and waterfalls and so on. So these are the sort of things that make us realize how dynamic the Earth can be. Big floods, dam breaks, and so on will cause a lot of erosion, even in bedrock landscape. So this sort of landscape.
So there's certain changes that can happen in days or weeks instead of thousands or millions of years. Is that what you're saying?
Yes. Yeah, and I think that's been one of the surprise. And satellite imagery is helping us a lot these days to really realize how dynamic the Earth is these things are changing very, very quickly. So going back to the Himalaya, for example, last year there was an event in a place called Melamchi. And what happened is that there was a storm which didn't look that big. And there was a landslide that blocked the valley. And as it blocked this valley, a lake formed behind the landslide. And then the landslide dam failed, and all that lake emptied into the valley and caused devastation down the valley. So there are places, for example, where a town has been buried under 10 meters of sediment. And that happened in a matter of hours. And if that landslide hadn't happened, it would have been a big flood, but nothing that spectacular. But because the landslide blocked the valley and formed that lake, it made the flood much more powerful, and it created a lot of erosion in the mountains. And where the valley opened up, it deposited, like, as I said, 10 meters of sediment. So the whole village has been buried under the sediment that was transported.
That's crazy.
Yeah, it's really impressive. And these things, like, some of these things happen in the high mountains where there is no one. But now with the satellite imagery, we manage to see these changes happening. We almost see the geomorphology in the making, because you can have images with just a few days difference. So you can really see the changes.
So what are some of the events, again, that cause the biggest change? Floods that come from melting of glaciers, or Just, cities that lie at the base of mountains, or like what areas are prone to be dramatically remodeled quickly?
Yeah, I would say that they're the areas where you're going to have a lot of water coming in a very short amount of time. So you can have, and that could affect equally places in the mountains where the big flood is going to cause erosion, but also places in the valley, in the low-lying area where the water is going to spread and cause widespread flooding. So the sudden release of a lot of water could come from big storms. It could come from lakes that suddenly empty into a valley. And that could be because you have a dam that breaks, for example. And when we think about dams, we tend to think about artificial dam made by humans. But when you go to mountains, there are a lot of places where there are dams, natural dams that are just made by debris, by an accumulation of debris, by a landslide, for example. And these things they can break. And when that happens, this is one of the major hazards, I would say, in mountainous areas.
I've been working too hard and not working out enough. I wanted to get in shape, but I don't have time to get to the gym. Echelon brings the gym home to me. So right now, for a limited time, podcast listeners get up to $800 off MSRP. To get this exclusive podcast discount, text GENIUS, GENIUS, to 818181 to get up to $800 off MSRP. Once again, text GENIUS to 818181, and message and data rates may apply. See terms for details.
So what's your goal now? Are you trying to look ahead to areas that could have problems and warn local populations, or what's the focus of your research?
Yes, that is one of the research that we're trying to develop. As I said, as I train as a geologist, and I used to look at processes over geological timescale. And when I started looking at sediments, I realized that, as you said, like the Earth is very, very dynamic. Things can change very rapidly on timescale of decades, even sometime at the scale of just a year, a monsoon season. You can have these big changes, and I started realizing that I can use my research to try to understand these hazards associated with sediment and flooding, and how we can prevent. Well, we can't prevent these things. Like the forces that are involved are too powerful, so we can't prevent them. But at least we can try to develop systems to detect the places where this is most likely to happen, and maybe put in place warning systems so that we may not be able to prevent the destruction, but we can at least tell people to move if one of these big hazards is about to happen. And we can also, what we're trying to do also is work with policymakers to tell policymakers where are the places where you probably don't want to build a road or a village, and places that would be safer in that context.
Okay. Any examples that come to mind right now and that we can go into a little bit of the details of?
I guess I end up talking a lot about in the Himalaya. I'm sorry, but this is where we've been doing a lot of our work recently. And we have a project at the moment looking at the Kathmandu Basin, which is, so Kathmandu is the capital of Nepal. And it is a city that's growing very rapidly. And it is in a low-lying area. It is in a basin that's quite flat, in the middle of the mountains. And because the city is growing, there's a lot of urbanization, there's a lot of road building that is being involved, but it's also trying to think about how we can help. So we work with researchers in Nepal as well, and it's thinking about how we can work together to help these developments being done in a sustainable way, but also where the hazards are really taken into consideration so that we can look on the long term and reduce losses. We're talking about human losses, financial losses associated with, for example, landsliding that may destroy big roads and cities, and flooding that may also cause a lot of damage.
Well, very good. What are some of the hypotheses that you're testing with your research?
Some of the hypotheses we're testing with the research. So I guess when it comes to the hazards, it's really thinking about can we look at the shape of the landscape and make predictions about where the next events are going to happen. that is probably the biggest hypothesis. And when I say shape of the landscape, I was talking earlier about satellite imagery, and what we've been working a lot in the past couple of decades is using satellite imagery to analyze the landscape, analyze the steepness of the landscape, analyze the shape of the valleys, their depth, and so on, and run algorithm that will tell us, okay, this area is more likely to be stable than this other area. What we can do also is, what we've realized with this data is that we can also look at the shape of the landscape to detect places where you may have active faults. So the active faults are where when a fault moves, it can create an earthquake, for example. And just by looking at the shape of the valleys, the shape of the ridges, mountains, and so on, you can also detect like faults that may be hazardous in that context. So the main hypothesis is I can use the shape of the landscape to assess, like to detect whether a place is going to be safe or not in terms of hazards. And we're talking about different hazards. We're talking about earthquake, we're talking about landslides, and we're talking about flooding in particular.
I thought it'd be funny to say that, earthquake scientists are very critical because they always try to find fault in things.
They are very critical, and they have to, because if they make mistakes, also they die. So they have a lot of pressure here. I would say that earthquake science has made a lot of progress. So we can tell where earthquakes are likely to happen. We can tell roughly when they're going to happen, but we can't say precisely an earthquake is going to happen on the 26th of June at 5 a.m. And I don't think we will ever get to that point, unfortunately, but we can at least make prediction about these areas is likely to experience a big earthquake an earthquake of that size in the next 20, 30 years. So I think we got to that point.
What, besides, let's say, a riverbed, the bed rising with sediment in it, what about the nature of sediment and soils that deposit in an area in general? The porosity of a sand. Mm-hmm. Let's say, a flood comes and it brings a whole bunch of sediment that's a lot finer grained than what was there before. Or, rocks fall and create like a filter basin or something. Like what, physical characteristics of the materials that are transported, the water, the sand, the soil, etc., affect an area and how?
That's a very good question, actually. Because, depending on whether a river is going to transport and deposit sand and gravel, for example, that's going to impact how the river is going to respond. So, for example, if you would imagine that if there is a big earthquake and there's a lot of fragments and the river ends up transporting a lot of gravel and depositing it on the riverbed or even on the floodplain, it's going to take a lot of work to be able to move that gravel again. So that may be something that ends up being a more long-term effect, and that may lead to changes that are going to persist for decades, maybe even centuries. Whereas if you have a river that is going to transport a lot of sand during a flood, okay, you may have big changes, but in the next flood, it may be easy for the river to move that sand around because it's easier to erode and transport sand. And so one of the surprises, you were talking about surprises as well, that we got into by doing our work. One of the surprises we had was to look at the effect of abrasion and how it influences how much gravel or much sand the river is going to transport. So when I talk about abrasion, I mean you've got a pebble that imagine it's the size of, 30 centimeters, a large pebble. Some of the work we've done showed that most pebbles will not survive transport distance of a few tens of kilometers. So most rock type, after a few tens of kilometers, the pebbles will have been reduced in size and crushed and reduced and turned into sand, for example, sand and mud. So it's only really the hardest rock that are going to persist as pebbles over a transport distance of a few hundreds of kilometers, for example.
So does some of the hardest rock, let's say, come from volcanic eruptions? Like, what if there's a volcanic eruption and there's a flood that picks up a bunch of this volcanic rock and it gets entrained in a river or it moves over a landscape. If it's particularly hard, would it scrape the landscape, or would it change a river dramatically because of the hardness of the material that's being transported through by water?
Yeah, that is totally true. So it depends what sort of volcanic eruptions you're talking about, because if you have a volcanic eruption that tends to be explosive, you're going to have a lot of ash and rocks that are quite porous, for example. So in that case, that will be evacuated by the rivers as sand and mud and so on. If you have a lava flow, on the other hand, like you would have in Hawaii, for example, or in Iceland, something that is deposited and forms like very hard rock, you're right. When the river is going to start transporting pebbles that are made of this hard rock, then it's going to erode the bedrock more easily than if it was transporting rocks that are not as resistant. So the type of rock that the river is transporting is having a big impact on the ability of the river to carve canyons, for example. So that's something we've been investigating as well.
So has any government or city commissioned you to go in there and to come up with preemptive plans to help them avoid a problem? Like, let's say they call you in, there's a river that flows by a town, and your recommendation is, hey, if you dredge it and you get 4 or 5 more feet of depth in the riverbed in this area, then you're going to avoid floods more likely.
Yeah. So we've been talking with researchers in Nepal mostly, but this is a problem that happens in the UK, for example, as well, and I'm sure in the US there are problems like that of riverbeds being raised. And what the research shows is that dredging is a very bad idea. It doesn't solve the problem on the short term. It solves the problem on the short term, but on the long term, it tends to destabilize the banks of the river, for example, so it can create other problems like bank erosion. But what people have been using, and I would say that is also a very bad idea, is something that governments use a lot, is embankments. So you build embankments to keep the water into the river. But the problem is that embankments, they're not your friends. When you put embankments in a river that transport a lot of sediment, for example, instead of rivers, they like migrating. They like migrating into their floodplain, and the natural process of a river would be to flood, and then it deposits sediment. And very often, that sediment that is going to deposit on the floodplain is going to be very good. It's going to make the land fertile, and so on. The moment you put the river in one place, then every time there is a flood, at the end of the flood is going to deposit the sediment in this one place. So when you put embankments, you tend to raise the riverbed. And in response to that, people have been raising the embankments. And that has created a lot of problems. So I know that there are places in Italy, for example, or in China, where the bed of the river is higher than the floodplain. So imagine you've got some flat land.
It's a disaster waiting to happen.
Exactly. And once you are at that point, I honestly don't know what you're supposed to do, because except if you try to reroute the river and give it another course, I really don't see. As you say, it's a disaster waiting to happen. The moment a bank fails, you just fill up the floodplain, and that leads to more disruption. And one of the problems as well is that it also gives the population a false sense of security. The moment government place embankments, people are going to start building houses on the side of the embankment because they feel like they're safe. But it's actually, it is a bad thing.
Has anyone tried to steer a river long term by doing one-sided embankments to change its course over months so that the river moves?
I actually don't know. I'm not aware of anyone who's done that. And I think one of the problem, one of the reasons why that may not happen is that it's easier to build cities and infrastructure on flat land. So in most countries where urbanization has happened, people have built things everywhere where there is no river. So cities, roads, fields, infrastructure have been built quite close to rivers. So there is always, if you try to move the river, it's going to end up flooding or destroying an area, even if you try to steer it in one direction. So I am personally not aware of anywhere where that could have been done, but you would imagine that indeed, if there was a place where you wanted to protect a particular area that was of high importance, you could potentially try to steer the river away with embankments. But I'm not aware of anywhere where that has been attempted.
Well, do you know if anyone has studied what makes a river, twist and turn? What kind of features make a river, again, do like a right turn or a left turn or get wiggly? Maybe those could be used, again, in selective engineering to slowly, change the flows of a river or move it or, change its bed composition, et cetera.
Mm-hmm. That has been the concept of river sinuosity, for example. That's been studied for decades and decades. You go back to the early geography work where people have tried to understand why some rivers are meandering, while others are braided, and so on. And there are some theories, and most of them tend to link with the how hard the banks of the river, how resistant the bank of the rivers are to erosion, and also on the amount of sediment that is being transported by the river. So depending on how much sediment there is, you may have rivers that migrate faster or slower, and so on. But unfortunately, this doesn't necessarily give you an answer, because the places where the hazards are the greatest, where are the places where you've got very big rivers, and you have very little control on how much sediment a river like that is going to transport, for example. So what people are trying to develop these days are what we call soft engineering, whereby instead of trying to control exactly the shape of the river by making embankment that will give the river that exact curvature that may remain on the long term, they tend to try to let the river develop its own course, but leave a corridor around the river that is large enough that the river can develop its own geometry, its own natural geometry, and can function the way it should be. So there are a lot of places, for example, where rivers have been straightened, and now they're changing that and they're breaking the embankment to make the rivers meander again, because it makes the river, for example, less flashy in terms of flooding. So the discharge will not increase as much as if it were straight. For example, the flow velocity.
Oh, because the water velocity gets dampened each time the river turns.
Exactly. So it's like I think that for a long time, people have been working on hard engineering, and it's really recently, I would say the last 2 decades, that they've realized that it's not working, and that trying to constrain nature is not working very well, and that this soft engineering offers the best of both worlds, because the hazards are reduced, the risk is reduced, but also rivers are able to develop their natural geometry. So that can have an impact on, for example, fish populations, ecosystem, and so on. So that is the big thing at the moment in terms of restoration, is soft engineering to make the best of both worlds.
Yeah, has anyone tried to split a river and make give it a second place to go?
I guess that in terms of limiting hazards, I am not aware of that. People split rivers all the time when it comes to irrigation, hydropower, and so on. And for example, I'm thinking about, again, some of these big Himalayan rivers, like the Indus. Some of the rivers in Western Himalaya are big rivers that are turned into canals, in so many canals that the river disappears, because there's so much water that is pulled in all directions from the main river that the river disappears, and all this water is used to irrigate fields, and that leads to additional problems, I would say, because the water essentially wants to make its way down to the sea.
Well, very good. Well, Mikael, what's the best way for people to find out more about your work? Where can they go?
So I've got a website with a bit of information about myself. I would say that, just one point I want to make is that I think if you're excited about earth science, and there are a lot of programs on the internet, on the TV, and I personally think that earth science is a really fascinating topic. But importantly, it's like we all know that the Earth is facing some global problems, and we need more Earth scientists to solve these problems. So if you're interested in Earth science, consider having, and you're young and you want to make a difference and you want to study a topic that's very exciting, consider having a career in Earth science. There's a lot of possibilities in terms of careers, in terms of research, in terms of industry, and just be curious and look around for information on the internet, for discovery channels and programs. That the Earth is a really fascinating topic to study, and we need more people studying that topic.
Okay, well, very good. Mikael, thank you so much for coming on the podcast. I appreciate it.
Thank you very much. Have a good day.
Thank you for listening. I hope you enjoyed the podcast, which has been sponsored by Echelon. When you're trying to reach your fitness goals, it can really help to have world-class instructors like Nicole Griffin and Michael Brown choreographing classes with music from your favorite artists like Pitbull. And you get a community of hundreds of thousands of people who can give you that extra push. Echelon gives you that. Echelon's certified fitness instructors are supportive, engaging, and fun. They really know how to get you moving. And right now, for a limited time, podcast listeners can get up to $800 off MSRP. To get this exclusive podcast discount, text GENIUS to 818181 to get $800 off MSRP. Once again, text GENIUS to 818181. Message and data rates may apply. Please see terms for details.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.